All right, guys, settle down and start. All right, the last chapter, the last section that we have to do is called primitive functions, which is where we are going from the derivative and we're trying to go back to what the original function would have been. We're trying to reverse the process. So it says there, sometimes you may know f dash x and need to find the original function f of x. This process is called anti-differentiation, and the original function is called the primitive function. Letter in. Thank you, Sammy. On soft. Okay. If we are reversing what we're doing, going from the derivative back, we have to reverse the process as well. So when we were differentiating, the power would multiply down the front and we would subtract 1 from the power. When we reverse that, we're going to be adding 1 to the power. So if the power is n, it becomes an n plus 1. And you, instead of multiplying by the power at the front, you're going to divide by it because that's the opposite of multiplying, okay? Also, because when we differentiate, all of our constants just disappear. Remember how that always disappears when we differentiate? It means that there could, when we're reversing the process, there could have been some number there that we have no evidence of, and we need to add a constant back into our equation. So that is why we have the plus c on the end. So let's go through the process. If I want to find the y from the derivative, we add 1 to the power, we divide by that new power, whatever n plus 1 is, and then we're going to add a constant onto the end. And this process is called finding the primitive function if it's going from the derivative back to the original. But next year, the very first topic that you're going to do is called integration, which is a lot more of this stuff, where you will be integrating the y equation to find things like area. Okay, so it does other things as well. All right, but for today, primitive functions. There's just going to be lots and lots of little examples here. They're short questions, but we do have quite a few of them. So to find a primitive function of dy dx equals x cubed plus x squared plus x plus 1, I'm reversing the process, so I'm going to be going back to the y equation. And for each term, I need to add 1 to the power and divide by the power. So the x cubed term, I'll add 1 to the power, which is a 4, and divide by the power. Then go to the next term. It's an x squared, so I add 1 to the power, becomes cubed, divide by the power. Move on to the next term. X, add 1 to the power, becomes x squared, divide by the power, become over 2. And the 1, if I'm going to add 1 to the power, I'm really adding an x, a 1x, and I've found the primitive function, but I have to also remember to add a plus c for any constant that could have been on the end. And that's it. You've done your very first primitive function. Let's do it again, lots and lots of times. Okay, so second one, dy dx, reversing the process, it's going to become y equals, the first term is 4x, adding 1 to the power will become a power of 4, and divide by that power, which you can see there's going to be some cancelling happens there. The second term is a 2. When I add a power of x, I'm adding an x, and I need to remember to add a c. So I would just do an extra line here so that I could cancel the 4 from the top and the bottom of that first term. So x to the power of 4 plus 2x plus c would be my primitive function. We will be finding out what c is towards the end of the examples. You have to be given more information to work out what that constant is. All right, part C, dy over dx. So reversing the process, I want y equals. It is 6x. I want to add 1 to the power, becomes a 2, divide by the 2. Moving on to the second term, it's minus 4. X to the power of 5 will become a power of 6, adding 1 to the power, divide by the power. And don't forget to add on your constant. You will actually lose marks if you forget to add on your constant as well. And I just want to go through and simplify each of those fractions. So 6 divided by 2 makes 3x squared. The second term doesn't simplify to a whole number, but I can divide top and bottom by 2 to be 2x to the 6 over 3 plus c. Okay, so we're just going to gradually add different types of things in here. D has negative powers, and we're also changing notation. We have f dash x, which means I will be finding the primitive or the original equation of f of x. So same process, even with negative powers. Keep the 2 out the front, keep the x. If you add 1 to the power, what am I going to get? 2/3, good. And you're going to divide by 2/3. I'll tidy that up on the next line. Moving on to the next term, it is x to the negative 5 over 2. Add 1 to that power would be negative 3 over 2, good. Dividing by negative 3 over 2. And then adding on your c. So for each of those fractions on the denominator, to simplify them, the number that is on the bottom is going to multiply up the top with the 2. You're imagining the leaf kiss flip part. So you're leaving the 2, so that fraction would turn upside down so that the 3 is on the top and the 2 is on the bottom. So you do 2 times 3, which is 6 x to the power of 2 over 3 over the 2 that stays on the bottom. And that, of course, is also going to simplify. But we'll do one step at a time. For the next one, there's no number up here, so all I have to do is flip that fraction upside down to be a negative 2x to the negative 3 over 2 over 3 plus the c. And one last little bit of simplifying. The 6 over 2 in the first term can become 3x to the power of 2 over 3, and that's... You could put the negative power on the bottom, but because there was negative powers in the question, it's okay to leave it in the same form as the question. Okay? All right, next page. Question 2, we have our derivatives in fraction form with x's on the bottom, which means that we're going to be having to move things away from the bottom so that we can find the primitive and then moving them back again. So the f dash x, before I can even find the primitive of that, I need to change that to be 3x to the power of negative 3. Okay, haven't integrated anything, just rewriting it, bringing the x up. Now I am in a form where I can do my primitive function. So no dash, sorry, anymore. It should just be f of x equals, and doing our thing. Leave the 3 from the front, add 1 to the power would be negative 2, divide by that power, negative 2, and add on your constant. Because the original question was in fraction form, this is when I would require you to put it back so that there's no negative power on that x, and we would have negative, you also usually move the negative, if there's one negative, move that to the front, negative 3 over 2x squared plus c. Yeah? Makes sense so far? Another one, part B. Again, I need to change the way that is written before I can find the primitive. So the minus 2 will stay at the front, and I'll bring x up, and it will get a negative power, x to the negative 5. dy dx will become a y equals. I will leave the negative 2. I will add 1 to the power, which becomes a negative 4 over negative 4, and plus the constant. Tidying that up, a negative on the top and a negative on the bottom, the negative signs will cancel out. The 2 over 4 would simplify to a half. So I have a 1 over 2, there's my numbers. The x to the negative 4, I want to move that back to the bottom to become an x to the positive 4 down here, plus c. Okay, you can see it's, once you get the hang of this, it's quite repetitive, it's just moving things into the right form so that you can deal with them. Okay, so next type, These are all the things that we learnt differentiating. Now we've got to learn to go the opposite direction. So now we have the surds, or the fractional powers. So again, I have to change that into a power form so that I can do the process. A square root of x is the same as x to the power of a half. So I'm using f dash x, so the primitive of that will be f of x equals. Add 1 to the power would be 3 over 2. Please always, when they're fractions like that, please always do them as improper fractions. And divide by that power, 3 over 2. And I will need to plus a c. Okay, but now I've got to tidy that up. So the fraction on the bottom, the 2 is going to flip up to the top, so it will be 2 over 3. The x to the power of 3 over 2 stays on the top, but if I'm putting that back into surd form, because the question was in surd form, 3 over 2 is the same as 1.5, which means 1 whole and a square root of x. So it's the same as 2 over 3, I'll leave that at the front, and then I have, there's my 1.5, like that. It can be on the top of the fraction. I could put it all on the top, or I can put it next. It means the same thing. Yeah. You can do root x cubed. Oops, that was a terrible square root sign. You could do that, but that's a surd that can be simplified, because in that you have got an x squared times another x, and the square root of x squared becomes the x root x. So it's not as simplified as the option that I did. Okay, but they are equal. All right, try it again. Part B, always turn it into fraction power first. So that one's going to be x to the power of a third. Excellent, because it's a cubed root, which means power of a third. dy dx, so the primitive is going to be y equals, add 1 to the power. What's adding 1 to the power? 4 over 3, good. Over 4 over 3, and plus your c. So again, deal with the fraction on the bottom first, turn it upside down, so it'll be 3 over 4. And the x to the power of 4 over 3 will be 1 whole, won't it? And another x to the third. So the shortest way to write that would be an x, there's my 1 whole, and a cubed root of x. There's my 1 1/3 plus c. All right, question 4. Moving on to the next type, which involves brackets. Reverse chain rule, that's right. So to do this, if you remember for the differentiation process, it was bring the power down to the front, multiply by the derivative of the bracket, and subtract 1 from the power. So when we reverse the process, yes, correct, Ben, good job. We're going to be keeping our bracket the same, but we're going to be adding 1 to the power, dividing by the power, and also on the bottom, you will times by the derivative of the bracket. What's the derivative of my bracket? Another 5. Don't forget to plus your c. Okay, so that would be 5x plus 3 to the power of 5 over 25 plus c. Now remember, if at any time that you were concerned that you had done it incorrectly, you could check it, you could differentiate it again and see if you got back to the same question, same answer as what you started with. Part B, do it again. So you got the brackets there, dy over dx, the primitive is going to be y equals. Keep the 1 minus 5x in the brackets. Add 1 to the power. Divide by the power and multiply by the derivative of the bracket, which is minus 5 plus c. That equals, got to write it all down again, just putting minus 50 on, well, the 50 will be on the bottom, and if we move the minus out the front, plus c. let's combine brackets and fraction, putting two things together here. So I'm going to have to change this to be, bring the denominator up, x plus 2 to the power of negative 2, so that I can now do my reverse chain rule for that. So it will be y equals, keep the bracket, adding 1 to the power, make sure you go the right way, negative 1, good, over the power, which is negative 1, multiplied by the derivative of the bracket, which is a 1. Okay, so that just gives 1 times negative 1 is negative 1. And bring the negative sign out the front. The only thing on the top of that fraction is the bracket, but I want to move that down to the bottom. So 1's going to come on the top, and it's going to be an x plus 2 to the power of positive 1, so I don't actually need that anymore, plus c. I don't even need the brackets anymore because there's no power there anymore. Okay? Do you need a booklet?
No, I left it on mine, so I'm going to go do it when I get back.
Okay. Part D. Surds. Okay, so now we're going to be combining a fractional power, but I'm going to need to put that in brackets as well, so it'll be 2x plus 3 to the power of a half. So we're combining fractional powers with our bracket. Primitive function will be y equals, keep the bracket, add 1 to the power will become 3 over 2, divide by that power, and add your c. Oh, wait, I forgot to times by the derivative, which is 2. Good. Yes, correct. 3 over 2 times the 2 means that it would just be the 3 on the bottom. So I can leave that as 2x plus 3 to the power of 3 over 2 over 3 plus c. Now, I had a look.
What's you? Let him in. You just spawned in. Oh, I had enough.
For this type of question, usually our rule is change it back into the surd form from the question. To do that for this question, I can do it. The 3 over 2 is a 1.5, right? So it would be 1 whole, there's my 1 whole bracket, and then the half would be the square root of 2x plus 3 all over 3 plus c. But that, unfortunately, even though that is putting it back into the same form as the question, is actually making it more complicated, and you wouldn't be able to use that very easily to do further things. So I checked the textbook answers, and they've been leaving these ones in that form. They just leave it in fractional power. So you can do that as well. So the textbook answer left those ones as fractional powers. Question 5. All right, so here we've got our f dash x, but it gives me extra information in the question. It tells me to find f of x if f of 1 equals 5. By giving me this extra information at the end means I can work out the c now. Okay, so first of all, you don't do that part to the end. You still have to find your primitive function exactly the same as what we've been doing. Always do that first. So if it's f dash x, it's going to be f of x equals 2, add 1 to the power, become x cubed over 3, minus 4x, add 1 to the power is squared over 2, plus 3, add 1 to the power is an x, plus the c. Okay, there's a little, I can simplify the second term, so let's rewrite that. The minus 4 over 2 just becomes minus 2x squared. So, okay, we've got our primitive function. F of 1 means if I sub in that x is equal to 1 into here, all these x's become 1s, then the y value would be equal to 5. Okay, that will be my f of x part. So I'm going to sub that in. I'm subbing that f of 1 is equal to 5. So the 5 goes where the f of x is, because remember f of x is just like a y equals, that's the y value. And all those x's I sub in a 1, so it'll be 2 times 1 cubed over 3 minus 2 times 1 squared plus 3 times 1 plus c. And so by doing that, all that's left in that equation, pronumeral-wise, is the c. So I can solve it to find out what the c is equal to. So all this yucky stuff here, type all that in your calculator, all they're ones, so they should be fairly easy to do in your head. Say it again. 5 over 3. So it's 5 equals 5 over 3 plus c. And so yes, oh, you're doing the final answer. Okay. The c, when you subtract the 5 over 3 across the other side, you will get 10 over 3. Don't stop, that's not the answer, because you have to rewrite your function with the correct c put onto it. So therefore my answer for f of x is 2x cubed over 3 minus 2x squared plus 3x plus my lovely constant, which is 10 over 3 that I had to find out. And now there's no more mystery. We know exactly what that original function was. No more plus c required. Let's try that again. We've got one more question.
Last ever question.
You're very sentimental, Lockie. All right, last question, and it will take most of this page because, have a look at it, it says f double dash is the second derivative is equal to 12 bracket x minus 1 squared, and we are told that the gradient at 0, so f dash of 0, and f of 1 are both equal to 0, and we want to find f of 4. So what we have to do, is from the second derivative, we're going to have to find the primitive to go back to the first derivative, find the constant. Find the primitive again to go back to the original function, find the constant, and then finally, once we have found the equation of f of x, we can then finally sub in the f of 4 for the final part of that question. Okay, there's a few steps here. So from the beginning, if I want to find f dash of x, okay, I'm integrating one step, or primitive of one step. I have brackets, so the 12 is going to stay there. The x minus 1 squared, I'm going to add 1 to the power and divide by the power, and we add a c. Now, simplify as you go, because it will make your life easy. 12 over 3 makes 4, x minus 1 cubed plus c. Okay, so we've done one step, but we now have to stop and find that constant before we can go on to the next one. So I have an f dash x, so I need to use the f dash x that is in here. It says f dash of 0, forget that part, equals 0. Okay, so I'm going to sub f dash 0 equals 0. So the f dash x is 0, and the x's that I'm subbing in are also 0. Don't think that that necessarily means that everything is 0, because it doesn't in this case. 0 minus 1 cubed plus c. 0 minus 1 is minus 1. Minus 1 cubed is still negative 1. Times by the 4 is negative 4. So c is equal to a positive 4. So my complete equation for the first derivative is 4 bracket x minus 1 cubed plus the 4 that I just found for the constant. One step. Now do all that again to find the original function. So now f of x. Okay, just one step at a time. Integrate that now. Leave the 4, leave the bracket. Add 1 to the power, divide by the power. Moving on to the constant, the 4, I have to add an x to that. Don't need to divide by 1, but thank you. And add the constant on the end. Simplify. The 4's will cancel. So I have x take away 1 to the power of 4 plus 4x plus c. Okay, so now I have an f of x equation. Ooh, can I see that back at the top of the page? Yep, there it is. I've used that part already, but this is a normal f of something, okay? That's into your f of x equation. F of 1 is also equal to 0, so I'm going to sub that part in now. So sub f of 1 is equal to 0. So the f of x is 0, but the x values I'm subbing in are 1. So it would be 1 minus 1 to the power of 4. That's just going to be 0. Plus 4 times 1 plus c. So that is just 0 plus 4 and the c, which means that c is going to be equal to -4. I now have all of the information to write down the complete equation for f of x. It is x minus 1 to the power of 4. It is a plus 4x, and it is a minus 4 on the end. Now that's really cool just to get to there, but we have one final thing left to do because the original question said, once I finally found that f of x, I want to find f of 4, which means I now have to sub 4 into that equation. F of 4 equals 4 take away 1 to the power of 4 plus 4 times 4 take away 4 equals 93. Good job. That's it.
Oh my.